I'm going to go over some of the discussions you should have had when you were doing 1.9, and I'm going to use number 6 to talk about it. So remember that when we're using function notation, x is the same thing as n, y is f of n. Make sure you're writing down everything I write down in your book. So this term right here is f of 1, and we also call that the start. So we know what the start is for this function by looking at the table. We also know down here that this term is f of 6 and that is equal to 10. And f of 1 here is equal to 40. We do not know the terms in between, and that's what we're trying to find out. We know that it's an arithmetic sequence, which means that there's going to be a common difference, which means that we're going to be adding either a positive or a negative number to get from one term to the next. And we want to figure out what that positive or negative number is. So one way to think about it would be to set up an equation to find the common difference. So some of you might have said that I know that I'm starting at 40. So I'm starting with 40, similar to how we write our explicit equations. And I'm adding some difference, and I'm using a variable because we don't know what the common difference is. Five times. Because to get from 40 to 10, it's 1, 2, 3, 4, 5 spaces. I'm adding whatever that common difference is 5 times. And when I get there, I'm going to have 10. Because that's my f of 6. A better way and how we usually would write this equation is 40 plus 5d is equal to 10. So again, I'm starting with 40, I know that. I'm adding some kind of difference, which is the d, 5 times. 1, 2, 3, 4, 5 to get to 10. So if we go ahead and solve that equation, 5d is equal to negative 30 divided by 5 divided by 5. We figure out that our common difference is negative 6. Another way that you could think about it is that we're trying to find our common difference, which I'm going to write another equation, and I'm just going to do it down here since I have space. So we're trying to find the common difference, which is d. Common difference. And I know that that's going to be equal to, and this is how maybe some of you did it on the previous page, any f of n value. So any y value, in this case it's f of 10, but f of n would mean any y value minus the first y value, which is f of 1, right here. And then I can divide that by how many spaces or jumps to get from one to the next. So in this case, the way I can write that in function notation is n, which is x, in this case it's 6, minus 1. So if I fill in my numbers here, f of n is any y value. In this case, I know my y value is 10. Minus f of 1, which is the start, in this case is 40. And then we're going to divide that by the number of jumps. This is sort of like finding the average. So the number of jumps is 6 is my n minus 1. 1, 2, 3, 4, 5 to get from 40 to 10. So that's negative 30 divided by 5, which is, again, negative 6. A third way to think about this would be to think about it more as an explicit formula. So I could start with f of n is any y value. In this case, it's going to be R10. That's going to be equal to whatever my start is, which is f of 1, plus the common difference, which we don't know what that is right now, to the n minus 1. Or times n minus 1. And think about why I did n minus 1. This table starts at 1, correct? So it's just like you're writing your explicit equation. Now if I go ahead and plug in my numbers, f of n in this case, any y value is 10. So 10 is equal to f of 1 is 40. We don't know what the common difference is. That's what we're trying to figure out. Times n, which is 6 minus 1. N is 6 because that's the x value there at the end. So again, I just wrote an explicit equation for this table, filled in everything I know. The only thing I don't know is the common difference. Sorry, you couldn't see that. So the only thing I didn't know is the common difference. So now I can just go ahead and solve for the common difference. 40 plus, distribute your d, so 6d minus d. So 10 is equal to 40 plus 5d. I can subtract 40 from both sides to get negative 30 equals 5d. Divide by 5, divide by 5. D is equal to negative 6. So those are three methods you can use for figuring out what the common difference is in these tables so that then you can figure out what the arithmetic means are. And remember that the arithmetic means, which it describes right here, are the numbers in between that we don't know. All right, flip your paper over. I'm going to do these examples again. This time I'm going to use number 2. Okay, so same 3 ways of finding the arithmetic means. You decide which one works best for you. So I'm going to start thinking about what I know. In this case, I know that my start is 18. So 18 is going to be equal to, oh no, wait. I'm going to write the explicit first. So 18 plus some common difference 4 times this time, because I'm adding the common difference 1, 2, 3, 4 times, is going to give me negative 10. So if I go ahead and solve this equation, I can subtract 18 from both sides. 4d is equal to negative 28. Divide by 4, divide by 4. D is equal to negative 7. Another way to think about it is sort of averaging the change in y divided by the change in x. So I can take any y value and subtract the first y value and divide that by the number of jumps that I'm taking to get from one y to the next. In this case, I would take negative 10 minus 18 and divide that by 5 as my n minus 1. So I get negative 28 divided by 4, which is equal to negative 7. Oh, off the screen. The third way is just to write an explicit equation. So we know that any y value is going to be equal to whatever the start is. In this case, the start is 18. Plus whatever the common difference is. Remember, technically, I don't know the common difference yet. Times n minus 1. And I did n minus 1 because x starts at 1. If I solve this equation, my f of n, I can substitute in because I know what my last y value is. It's negative 10. So if I solve, and I can also substitute in n. I know that n, when y is negative 10, x is 5. Remember, you only want one variable, so you can solve for that variable. So now if I solve, I can let's distribute first. So negative 10 is equal to 18 plus 5d minus d. Negative 10 is equal to 18 plus 4d. Subtract 18, subtract 18. Negative 28 is equal to 4d. Divide by 4. Divide by 4. Negative 7 equals d. And then you can use that common difference to figure out the missing terms in the table. So choose which of these 3 methods makes most sense to you, and that's what you'll use to find the missing terms in the sequence.